Welcome back to the another session of our data structure journey. Today we are going to cover what is a double linked list, what are the basic operation with advantage, disadvantage, application, as well as we calculate the time complexity of each and every operation. So this is our outlines. We cover introduction to the double linked list, then some time complexity. So let's start. So double linked list is a variation of linked list. What is a linked list? We are already covered in our session. In our description section also I put each and every link. So where navigation is possible both way means list of elements that link together as well as it can be traversed to either forward direction or backward direction because there are two pointers. So this is our structure declaration. This declaration is in the C language because we are going to implement in the C language. So integer info means the node consists of three things. So here the node is consist of three things. First one is the information we are going to store. Then one pointer which store the address of next node. So this is a pointer which store the address of next node. Now this is the next node. Address is 400. So it store the address of 400. Then another pointer that store the address of back node. So this for this node, this is the back pointer. It store the value 200. What is 200? 200 is the address of previous node. So double linked list means list of elements connected together in such a way that each and every node store the information of its next node information as well as its previous node. And starting node previous store the null values as well as the last node next pointer store the null value. In our implementation, we take two pointers, start pointer point to the first node of the linked list, last pointer points to the last node of the linked list. So this is the representation of the double linked list, and we are going to store the information 10, 20, 30, 40. So information we store the 10, 20, 30, 40. So this is a list of 4 elements. So what are the basic operation we can perform by help of the C language? So first one is the insertion. Insertion means adding an element into the linked list. So whenever we go for insertion, there are three classification. First one, we have to insert into the begin or first position of the double linked list, or we are going to the insert at the or adding an element in the end of the linked list or last of the linked list, or any specific position we want to insert, that is either second position or third position or fifth. So depend upon the user, we can insert the element into a specific position. So it can be possible. So this is the first operation, that is the insertion. Then deletion. Deletion means removing an element from the existing linked list. So deletion again classified into three types. First one is the deleting from the first node of the double linked list, or deleting the last node of the double linked list, or deleting any specific position of a double link. So there are three classification we can able to do it. Traversing means we are visiting each and every node of the linked list from starting to end. Searching means we are searching an element in linked list whether the element is present or not. So these are the basic operation of double linked list which are we are going to implement in the C language. So first one is the insert at the beginning of double linked list. So this is our function, or we can say it is our algorithm. Right now it's algorithm. So this is the function name insert begin, which does not return any value. So here what happened? First allocate the memory, then we check whether PTR equal to null. Means memory allocation is not done. So whenever you go for memory, whether it's memory allocate or not. So it is not. Then if it is memory allocated, we have to read a value, store the value, then we have to check whether we are going to insert into a empty linked list, or we have the list have some element, then we have to perform the operation. So this is the algorithm for insert into the begin of the. So in all the details of how the each and every statement is going to execute, I have already done one long video for this. I will put the link in description section. You can go to that section and understand details. Next one is the traversing. Traversing means visiting each and every node. As the double linked list have two pointer, that is the next pointer as well as the back pointer, here we can traverse both the direction, means we can traverse the forward direction as well as the backward. Whenever we go for backward direction, it is a reverse of the linked list. So we have to check whether list is empty or not. If list is not empty, then we have to traverse. So we store the start and we make the traverse into the end, means start to last of the node. So this is we call as the forward direction moving. Then backward. If you go for backward, so we have to store the pointer starting from the last to end of the starting of the linked list. So this is the way we can present. Next one is the inserting at the end of double linked list, means we are going to insert into the end position. So this is the algorithm. Whenever you go for end relay, we have to check whether list is empty or not. If list is empty, then this is the statement operation we have to perform. If list has the element, means then we have to perform this operation. So then we have to perform this operation. Then insert at specific position, means linked list is present and we have to insert in the specific, whether it is a 1 or 2 or 3 or 4. According to that, we have to go for the operation. So this is our algorithm to perform and it is written in a C language. So we have to check whether list is position we are enter 1 or not. If we enter whether it's a list is empty or not. If we a position is enter, then it has more than more have elements or not. So there are so many classification. First cases is position is 1. Then we have to perform check whether the list is empty or not or list is have element. Else if we have to check whether it is in between the position or not. That's why we are first count the number of element present inside the link. According to that, we check whether the position we are enter is within the range or not. If it is range, then we have to go to the specific location of this node. Then we have to insert the element. So these are the statement we have to follow. Otherwise, we have to write down the invalid position is that is the out of range. For example, there are 10 elements and we enter the position is 15. So at that time, it is not possible to insert. So all the details I have make a separate video. I will put inside the description link. You have to go to that section and understand it. Then deletion. Deletion also three type begin, end, any position. So this is for the begin of the linked list. So first we have to check whether list is empty or not. If list is empty, we cannot delete. No element is present. Then we have to check whether list has single element or not. If single element, then what happened? After deletion, we have to make start as well as the last as a null. If list have more than one element, then we have to adjust the start pointer. So these are the statements. So this is the algorithm to implement. So next one is the deletion at the end of the double linked list. So deletion means removing an element. So here we have to check whether list is empty or not. If list empty, we cannot perform deletion. Otherwise, we have to check whether list has single element or more than one element. So according to that, we have to make changes. So then deletion at specific position. So here what happened? We have to check whether list is empty or not. If list is not empty, then what happened? We have to check whether position is 1 or not. If the position is 1, then we have to perform certain operation. Otherwise, we have to check whether within the range or not. Within the range, then only deletion can possible. Otherwise, we have to write down the error message that is position is out of range. Then searching an element means list is already present. We have to search an element. So we have to start from the start node and we have to go to the end of the linked list and we have to search. Whenever we got the value, then we have to print it is present. Otherwise, we have to traverse. At end of the loop, we have to check whether the element is present or not. According to that, that's why we make a flag equal to 0 means initially we assume that element is not present. Whenever element is present, we make the flag equal to 1. Once the for loop is over, if element is present, it will print. Otherwise, at end of the for loop, we again check flag is 0 or not. If flag is 0, then we have to print it is not present inside the linked list. So time complexity. Time complexity is the number of time consumed for the operation. So insert at the beginning of the or end. So it is order of 1 because we don't have to traverse. We have to just make certain operation for changing. Let us take the example that is the inserting in the first position. So this is for insert in the first position. So what are the operation we are perform? So if list is empty, then this is the three statement you have to execute, means it is a constant time. Otherwise, this statement we have to perform operation. So if we go for this statement, then what happened? This is a constant time or not? That's why insert at first position each and insert at the end position. So the insert at end position. So this is also this constant time period or not? To perform this statement, we require constant time period. That's why insert at the first position, insert at the end position, time consumption is 1. Let's take the display. If we go for display, then what happened? We have to traverse entire list from starting to end to start. So if there are n number of nodes, we have to traverse n time. That's why the traversing or display of a double linked list order of complexity is order of n. Similarly, if you go for the deletion, what happened? This is the algorithm. If this is the algorithm, means this statement only we have to execute this 4 statement. After that, this 5 statement we have to execute. So this 5 statement or 4 statement require a specific time period or not? Only for once it will execute. That's why it is order of 1. If we go double linked list deletion at end, also here also same thing. We have to only perform this operation or this operation. So that's why the time complexity is order of 1. But if you go for the specific position, here what happened? We have to traverse to the specific position. Position can be 1, 2, 3, or 4, or 5, or 6. For example, 10 elements. We can go for the 10th position. So at that time, how many times the for loop is executed? 10 times. So 10 times the same thing we have to perform or not. After that, only the statements are executed. That's why the order of complexity of the deletion at specific position is order of n. Searching also, we have to traverse first node to the last node. That's why here also order of time complexity is order of n. So according to that, insert at begin or end is the order of 1. Insert at specific position, order of n, because for the position we have to traverse maximum up to n. Deleting at begin and end is order of 1. Deleting at specific position means 1, 2, 3, for any position, there are n number of elements, so we have to traverse n times. That's why the order of complexity is order of n. Time complexity. Searching an element, we have to go for linear search from 1 to end of the linked list. That's why the time complexity is order of n. Then access time means we have to go to a specific location, so it is also access time. This is our menu drive program which we are completed, and this one also we are completed partially one by one function we are added, and there is a long video each for each and every operation of this menu drive program. I also put in my description section. You can go to that description section and understand all the things. So this is our menu drive program. Insert at begin, insert delete in the first position, then delete in the last position, then specific position, then display function, that is the forward direction, backward direction, insert at end, insert at any position. So this is all the things, searching an element, then find out the maximum and minimum value also. This is our main function menu drive program. Let us compile and execute this program. So this is our double linked list. All the operation is given. For example, I make one insert at begin. So we insert first element, then insert 30. So now we have to go for display 7. 7 is the display. So first value we inserted 10. As it is inserted first position, that's why 10, then 20, then 30. So this is the forward direction, 30, 20, 10. Backward direction, 10, 20, 30. If we go for insert into the end position, now I enter the 40, then 50, then 60. Then I go for display. Just see, previously insert in the first position, we make the 10, 20, 30. After that, we perform the insert in the last position. So for after 10, right now, this is the previous linked list. Now end position 40, 50, 60. So again, we have to go for specific position. So this is our double linked list is present. For example, I insert the position is 3. Insert the value 33. So first, second, third. So this position we want to insert. Okay. Then we have to go for display 7. First, second, third. Third position we inserted 33. So insert at specific position. Now we have to go for delete. Delete means linked list is 30, 20. So if I go for delete at delete from start means it will delete 30. So I go for delete. 30 is deleted. Because 31st one. If I go for 5, 5 is delete at end position means 60. 60 deleted. Okay. If I go for space any position, if I go for any position, first we have to see first, second, third. So this is the third element. Okay, already it is deleted. Let's see how many elements is present right now. Right now, this is the element. If I go for delete at specific position, if I enter 3, 3 is first, second, third. So 10 is deleted. Yes, 10 is deleted. Specific position is deleted. Then search an element. Okay. So now if I go for 7, these are the element is present. So I have to go for search. Search is 8. For example, I enter 27. 77 is not present. Yes, 77 is not present because list right now consists of 20, 30, 40, 50. Now again I go for search element that is 33. 33 is present inside the link with the position 2. 33 second position, let's see. 33 is the second position, yes, first second position. Then max, minimum and maximum value. So maximum value is 50, minimum value is 20. Let's see. Maximum value here 50, minimum value is 20. Yes, we got the correct answer. So this is the menu drive program. Each and every part of the program I have done in the long video that I also put in my description section. You can go to that section also. So this, what are the application of the double linked list? So we can implement in the tree. Tree is a structure where from the from parent side, two children can be or any number of children can be possible. So for the children, for the two children, we needed two pointers. So here we can perform the implementation of data tree data structure by help of the double linked list. We can perform redo or as well as the undo. So undo redo means it is a previous as well as the next operation we have to perform. So for that we record two pointer, back pointer as well as the next pointer. Also we can perform the navigation. Navigation, we can also perform the navigation where the both forward as well as the backward diverse is required. By help of the double linked list, we can able to do numerical program utilize the R capability on doing the redoing action. So whenever you go for numerous application where the have to perform undoing as well as the redoing action, at that time we have to use the two pointer. That pointer practical implementation we can do by the double linked list. Then in our operating system we can go for the catchy construction, that is the we require, that is the most recently used or the least recently used item. So for that we are using double linked list. Thread scheduler. So thread means whenever we go for the multi-threading program, what happened? More than one thread can be executed simultaneously. Then in main question is that how the CPU scheduler decided which thread is going to be executed depend upon the thread scheduler. So thread scheduler has to decide which thread is going to be executed inside the active process, because inside a processor only one process can be executed. So this also done by the thread scheduler, and it is practical implementation is done by the double link. So these are the application of the double linked list. So what are the advantage? The advantage is that the double linked list, we are using two pointers, so it traverses both the way. So in case of single linked list, what happened? We can traverse the forward direction. For example, we want the reverse of a list. At that time, so many calculation we have to do. But in case of double linked list, simple, we have to traverse from last pointer to the first point. So reverse of the linked list is over. It also used to reverse the doubling, maybe it's reverse switching the next previous, so it can be very easy. No deletion. Because in case of single linked list, what happened? Whenever you have to go to delete, you have to keep the pointer, previous pointer as well as the current pointer. But here, in case of deletion of the double linked list, we don't require, because if we go for the specific position and the position we make the temp, previous node temp back, next node is the temp next. Immediately we can make the connection. So it is easy compared to the double single linked list. So what are the disadvantages? So if you go for array, to store the 10 elements, memory requirements is 10 into 4, that's the 40 bytes. If you go for the single linked list, it required more memory than the array, because it stored the extra memory for a pointer that points to the next one. If we go for the double linked list, again the extra memory is required for the back pointer. So as per the memory consumption, it's required more memory. This is the main drawback. Since element in the memory stored randomly, therefore the elements accessed sequentially or no direction is allowed. Here sequentially we cannot able to traverse. We have to go for the pointer wise, because that all the elements stored in the random match. Traversing random can be slower than the traversing of single. Because we the do pointers is there, that's why the traversing can be possible. Reverse side the um, traversing is possible, but time consumption is more compared to the single linked list, and implementing as well as the maintaining double linked list can be more complex than the single, because two pointer each and every operation we require more things to do for the, not only for only the next pointer, we have to take care of the back pointer also. These are the disadvantages of the double linked list. Hope you are able to understand all the concept of the double linked list. And for each and every operation, I make a separate video. Also, I put in my description section so that you can go to that section as well as understand the concept. There, I completed with all the things with the theory as well as the practical implementation in our C language. Thanks for watching the video. Please subscribe the channel.